This is LeetCode 2929, Distribute Candies Among Children II. This is the daily problem for June 1st, 2025. So I think it's a pretty good combinatorics problem. Basically, you're looking at the number of ways to distribute n candies among 3 children, subject to the constraint that no child has more than limit candies. And limit is variable in this problem, so you're going to have to handle that. And, I guess, the brute force approach here, you could do it in polynomial time. You could, loop through 0 and limit -1 for the first 2 children, and then the third is just going to get the remaining, and then, that's O of n squared. And the other version of this problem, so this one is the same exact prompt, and it's an easy, whereas this one's a medium. And the reason is because n is pretty small here, so you can get away with the polynomial time solution. But of course, with combinatorics, you can do this in constant time. You can see n is pretty big here. So that's what I'm going to be walking through here now. Generally, I think the first thing to recognize is that you're looking at n objects in k groups, right? The number of ways to distribute n objects in k groups. So that's basically, that's going to be stars and bars, right? So n plus k minus 1, choose k minus 1. That's the number of ways to distribute n objects in k groups. So this is essentially going to be the universe, right? This is going to be the universe. So the total number of ways that we could possibly have this, right? So, total equals combinations of, and k is 3, right? So in this problem, we have 3 children, so there's 3 groups, so k is 3. So essentially what we have is n plus 2, choose 2, right? So n plus 2, choose 2. And then we have, we have to deal with this constraint, right? No child gets more than limit candies. So we want to essentially subtract from this number the number of ways where any of the children could have more than limit candies. So to find that, it's going to be inclusion, exclusion, right? So if, this is the universe, right? These are all the possible ways. So, and that's this here. So, we have 3 children, right? So A, B, C. And then, let's say event A is the event that the first child exceeds the limit, right? So we're going to have that circle. Event B is the second child exceeds the limit, and event C is the third child exceeds the limit. That's what this is going to look like. And what we want to do is we essentially want to find this area, right? We want to find this area where we haven't exceeded the limit for any of the children, right? So we want to find that number of ways. So essentially what we need to do is we need to subtract from this the union of these 3, right? So A, U, B, U, C, right? And then we can do inclusion, exclusion to get this. So this is going to be A plus B plus C minus the intersections. So minus AB, minus AC, minus BC. And then finally you add back the middle, so A, B, C. So we're taking all the possible ways and subtracting the ways where at least one of the students gets, or at least one of the children, I should say, exceeds the limit. So we're going to have 3 events, right? The event where one student gets more. The event where, I keep saying students, I mean children. 2 children get more, and then 3 children get more. And then we're going to return total. And then it's going to be minus this, right? So we're going to do minus number of ways where one student can have more, add back the number of ways 2 students can have more, and then finally subtract the number of ways 3 students can have 4. That's coming from here, right? That's coming from right here. So how do we find these, right? Because this is what we want to subtract, right? So to find 3 more, right, we essentially want to reserve limit +1 candies for one of the students if we want one of the students to exceed the limit. So we're basically going to look at the same combination, but we're going to subtract limit +1, right? Because we know we want to reserve limit +1 candies for one of the students, and then we have this many candies left to divide after that point. We're still going to be dividing among the 3 children, though. And so there's 3 ways that can happen. So we're going to multiply by 3. And then we also want to ensure that this is going to be greater or equal to 0. So that else 0, because, or actually, we want to ensure this, the -2 here, the +2 and the 2 here, so it's actually just n minus limit +1 has to be greater to 0, because we want this number to be at least this number, right? That for the combination to make sense. And then we can rewrite this equation. And this actually makes a lot of sense because if we want to assign one child past the limit of candies, we need to make sure our n is at least equal to limit +1, right? Because if we only had 5 candies and the limit was 10, there's going to be no way to assign a child excess candies exceeding the limit. So, n has to be at least limit +1. And then likewise, the number of ways where 2 children can exceed is going to be pretty similar. So there's 3 ways that can happen, right? So the 3 stays, and then now we have to reserve twice limit +1 because 2 students need, or I keep saying students, oh my god, 2 children need to exceed the limit, and then this is going to become 2 times over here, right? Because now our n has to be twice as large for 2 children to exceed the limit. Finally, for 3 more, so this is going to be the number of ways where all 3 children exceed the limit. And so there's only one way that can happen. And so, well, I shouldn't say there's only one way that can happen, but we don't have to multiply by 3 because, there's only, we're looking at all 3 children now. So this becomes 3, this becomes 3, and yeah, I think that would work unless I'm missing something. I think this would work because, yeah. So yeah, that works. Once again, it's just inclusion exclusion principle. So that's pretty optimal. Once again, like I said, this is constant time, and yeah, I think this solution is pretty straightforward to me. So this is the one I went with, and I'll probably make more videos for the daily LeetCode problems. I'm like super tired right now, but I just wanted to document my solution for this problem. So yeah, that's it for now, I guess.